All right, this is our lesson on factoring expression. It comes right after our distributive property lesson. And you'll kind of see how the two tie together pretty closely here as we go along. But go ahead and get your notes page set up. We got our title here, Factoring Expressions Lesson. We've got our learning target, 6EE3, apply the properties of operations to generate equivalent expressions. And then here's our I can statement, what we hope to achieve by the time we're done. I can use factoring to find an equivalent expression. So it's a way of rewriting our expressions to find something that is equal to it. So let's go ahead and get started. So here's our definition for factoring expressions. It's dividing out the greatest common factor, think GCF, from the terms of an expression. So you notice here in the middle, here's how I kind of think about factoring. It's kind of distributive property backwards. With distributive property, we take the number on the outside of the parentheses, multiply it through times each of the numbers on the inside until we end up with just two pieces. For factoring, what we're going to do is we're actually going to go in reverse. We're going to look at our two numbers, 12 and 16, and see what do they have in common. What's the biggest factor they can both be divided by? Well, in this case, both 12 and 16 can both be divided by 4. So I can think of 12 as 4 times 3. I can think of 16 as 4 times 4. You'll notice they both have a factor of 4 being multiplied. So what we're going to do is we're actually going to pull out that 4 out to the front of the problem. We're going to divide out that 4 from both pieces. So what's left is just 3 plus 4. Those leftover numbers here, the 3 and the 4, that's what stays inside of my parentheses. I divided out what they had in common. Since it came from both of them, I could pull it outside of the parentheses, and I'm left with this for my answer. Same thing over here, even though I have a variable involved. I have 3x and I have 15. So what I asked myself was, what can both 3x and 15 both be divided by? What do they have in common? And what comes to mind is 3. 3x is really just 3 times x. 15 is really just 3 times 5. They both have that common factor of 3. So I'm going to pull those 3's out. I'm going to divide them out and pull that common factor out front. And then what's left stays inside of the parentheses. Like I said, it's kind of like distributive property backwards. I'm going to end up with a problem that looks like it's using the distributive property. 3 times, then in parentheses, x plus 5. A good way to double check a factoring problem is go ahead and use the distributive property and multiply it back out. 3 times x is 3x. 3 times 5 is 15. So I did get exactly what I originally started with. So I know I factored it correctly because I could do it in reverse and get back to my original answer. So let's do a quick review of how do we find the greatest common factor. Remember, it's the biggest factor that both numbers have in common. Remember, factors are the smaller numbers that we can use to make our larger number. So let's use this here in the middle as our example. Find the GCF of 12 and 18. If you remember from our lesson earlier in the year, there's 2 ways to do this. First, just list out the factors for each number. So in this case, it's what could I multiply together to get each of those numbers. For 12, I have 1, 2, 3, 4, 6, and 12. So you can just kind of sort through your multiplication table. For 18, I have 1, 2, 3, 6, 9, and 18. I'm thinking of all the combinations of numbers that I can multiply together to get 12 and 18. Then I sort through the list. There's lots of numbers that show up in both of my lists, but I want the greatest number. So in this case, that would be 6. It's the largest number that they have in common. So that was one method. List out the factors, just make sure not to miss any, and look for the biggest one that they have in common. The other method was to use a factor tree. So you probably remember these. This is where you broke each number down into smaller pieces based on what could it be multiplied to get. So 12. 12 is the same thing as 3 times 4. So I break it into a 3 and a 4. 3 can't be broken down any farther. It's a prime number, so it just stays as 3. But 4 can be broken into a 2 times a 2. Once you've broken them down into prime numbers, you stop. So 12 became 3 times 2 times 2. 18 can break into a 2 and a 9. 2 is a prime number, so it's going to stay as a 2. 9 can be broken down into 3 times 3. Again, when you break them all the way down to prime numbers, 2s, 3s, 5s, 7s, you know you can't break those branches down any farther. And then remember the trick. You go back and you look at those two lists and decide what showed up in both of those lists. Well, they both had a 3 and they both had a 2. 3 times 2 is 6. My greatest common factor is 6. So whichever method works best for you, feel free to use it, but it's just looking at building what's the largest number, what's the biggest factor that the numbers both have in common. So let's try factoring these two problems. So first we want to do 9 and 21. Again, these aren't a problem where we just want to go ahead and just add these two together. We're trying to factor out this expression to give us a little bit of practice. So you should be asking yourself, what do both 9 and 21 have in common? Well, for 9, I have 1, 3, and 9 for factors. For 21, I have 1, 3, 7, and 21 as factors. We sort through the list. The biggest number in both lists is 3. So that's the number I'm going to divide out of each of these pieces. So 9 becomes 3 times 3. I pull out that 3 out front. 21 becomes 3 times 7. I'm just breaking them both down into multiplication problems that have that same common factor in them. Because we have that common factor of 3, we can pull that common factor out front, and then my leftover pieces are what stays inside of my parentheses. So 9 plus 21 becomes 3 times, and then in parentheses, 3 plus 7. So 80 and 56. Again, list out your factors for each one of them. Use your factor tree for each one of them. Okay. Let's see what we can find for it. I'm going to try my factor trees. 80 and 56. So I'm going to get 8 and 10. This becomes 2 and a 4. This becomes a 2 and a 5. This one is prime. 4 becomes a 2 and a 2. And then my 2 and 5 are both prime numbers. So it looks like I'm going to end up with a pretty good sized number here. Here I have a 7 and an 8. Because 7 times 8 gives me 56. 7's prime, so it's going to stay. 8 breaks down to 2 times 4. Again, the 2 is prime, but the 4 can break into a 2 and a 2. And when you're all done, compare those lists together. What showed up in both lists? Well, they both had 3 2's. So I take those 3 2's and multiply them together. That's how I find my greatest common factor. In this case, my greatest common factor is 8. So I'm going to divide out an 8 from each one. So think of 80. 80 is really 8 times 10. 56 is really just 8 times 7. I have that common factor of an 8. So I'm going to kind of pull that factor back out, kind of the distributive property backwards. So I'm going to pull out that 8 out front, and then I'm just left with 10 plus 7. Now, I know we could just go ahead and just do this as a regular problem, but this is really just giving us a practice on how do I look for and find something that I can divide out, that I can pull out of that problem. So let's see what happens when we have a variable involved. Now, I know the variable kind of throws us off, but don't let it. You're really just focusing on the number parts here. You're trying to figure out what do both 4 and 16 both have in common. What's the biggest number they both have in common? You can list out your factors, you can do your factor trees, but what you would find is that 4 is the biggest number they both have in common. So we break down each one of them based on that 4. 16 becomes 4 times 4. 4x becomes 4 times x. So I just divided out that common factor. Well, now I can pull out that common factor. I can pull out that 4, and then I'm left with 4 plus x. So I'm dividing both numbers by the same factor. That's the number that's getting pulled out front. Whatever is left after I do that dividing stays in my parentheses. Let's try one more here. 36x plus 30. Go ahead and think about what could both 36 and 30 both be divided by. What's the biggest number that goes into both of them? Hopefully you came up with the answer of 6. They both have 6 as a common factor. So 36x, I divide out the 6. So I'm just left with 6x. 30 divided by 6, I divide out that 6, leaves me with 5. Now I have that common factor. I have that 6 that I can kind of pull out of the problem because they both have it. That comes out front. And inside I'm left with 6x plus 5. A good double check is when you're done with the problem, use your distributive property to go ahead and multiply it back out. See if you really do get the same answer you started with. So let's try. 6 times 6x is 36x. 6 times 5 is 30. Remember your rainbow method. That number on the outside gets multiplied times each of the numbers on the inside. Again, we're just checking it work. 36x plus 30 matches what I started with. So I know that I factored the problem correctly because when I went back and used the distributive property, it went right back to where I started. So that's what we're looking for when we're factoring. What can I divide out of both terms or all of the terms in order to pull that common factor out front?